Good afternoon, everyone. Welcome and thanks for joining us today. I'm Emily McGraw and I'll be facilitating today's webinar. During today's presentation, attendees will be in listen-only mode. If you experience technical problems, please use the questions pane of the GoToWebinar control panel. I'll be monitoring that area, especially during the start of our presentation today, so I can offer assistance if you need it. You may also use the questions pane at any time during today's presentation to ask questions you may have during the talk. Questions will be addressed at the end of the presentation. So we are pleased to have Adam Smith with us today. Adam Smith is an applied climatologist at the Center for Weather and Climate. He performs research to homogenize and transition disparate disaster data sources into better quality controlled disaster cost frameworks as research tools and has expertise in developing methods to quantify natural disaster costs and uncertainty. Smith regularly briefs the U.S. Subcommittee on Disaster Reduction on U.S. disaster costs and serves as NOAA expert on the U.S. disaster loss data in support of the International Sendai Framework for Disaster Risk Reduction 2016 to 2019. Smith is also a member of the NIST National Windstorm Impact Reduction Program, the American Meteorological Society Committee on Financial Weather and Climate Risk Management, and the Integrated Research on Disaster Risk Interdisciplinary Working Group on Natural Disaster Risk Loss Data Integration. So Adam, whenever you're ready.
Hi, thank you, Emily, and thank you for this webinar today. So I will spend about the next 30 minutes giving a relatively high-level overview of these U.S. billion-dollar weather and climate disasters, particularly focusing on 2018 and putting that in historical context, because as we all know, it's a challenge to understand how disaster costs are changing across space and time because there are so many variables that go into it. So let's dive right into the presentation. So here's the outline. It's basically 4 sections. First is the context for measuring disaster impact. Secondly is I will go over the data sources we use and what we're actually trying to measure, also what we're not trying to measure. The third section is the 2018 U.S. disasters in review. And finally, disaster cost comparison, looking at different disaster types across space and time and across different economic variables. So we at NOAA's National Centers for Environmental Information are split into several different centers. I sit with the Center for Weather and Climate. And as many of you know, NCEI has long been the nation's scorekeeper regarding tracking values, trends, anomalies across numerous weather and climate variables. And as part of this, of course, we ingest and quality control and create products and services for the general public and also, well, for the private sector in the whole world. And one of the pieces of information that is gaining more and more interest are extremes and disasters and what those impacts are on society, on industry, et cetera. And one of our products, as most of you have heard, is about the U.S. billion-dollar weather and climate disasters. Now, of course, $1 billion as a threshold is arbitrary. But what's interesting to note about events that have reached $1 billion in total direct losses or greater is that it actually represents a majority of the full distribution of losses for all weather and climate-related events at all scales and all loss levels. Munich Reinsurance also did this analysis back in, I think, 2011, and we've done the same analysis. And if you see at the bottom of this slide, what you'll notice is a rising percentage of the full distribution of costs which are related to these billion-dollar disasters. So in 1980, when we started this product, for the first 2 decades of the product, basically 75% of the full losses for all disaster types were captured by these billion-dollar disasters. But as you can see, as we progress forward in time, for the first 30 years, then it went from 75 to 80% of the full distribution is captured. And then finally, 1980 through 2018, we have roughly 85% of the full distribution, which is about 1.67 trillion of 1.96 trillion dollars of losses. And of course, there are many reasons for this. Certainly, the growing exposure and growing vulnerability, so that's where we build and how we build, play large roles. in this increase of loss. But it's also important to note that climate change is playing a role in some of these extremes. For example, we're having longer wildfire seasons out west. Also, we've noticed, of course, more extreme precipitation events, and so certainly there are many facets to this rise in risk. So there are, of course, also different ways to measure disaster impact. On the left side of this screen, you'll see the different disaster types we're including in this product, with the exception of the lower left, which are geophysical events. We have historically not included earthquakes or tsunami or like mud flow or landslide events in this data set. We perhaps could include that in the future, but for now it's severe local storms, wildfires, non-tropical inland floods, hurricanes, droughts and heat waves, winter storms, and I think crop freeze events. So 7 different perils. The center panel shows what we're trying to measure and what we'd like to measure. The green boxes denote where the best data exists. So that's public infrastructure, public and private property. A lot of this is because of the insurance sector. But of course, disasters have much broader impacts than just physical damage to contents and time element losses. There's also human losses, healthcare related loss, environmental capital, and the purple and blue boxes. But unfortunately, those data are not yet available in consistent space-time manner. They're too heterogeneous across space-time. And I'll get into that in a bit at the next slide. So here, we're going to look at the public and private data sources and what we're trying to measure. So I apologize for this eye chart here. It's a bit hard to read perhaps, but what we're trying to do indeed requires a broad array of public and private sector data. For more than 10 years, we've had non-disclosure agreements with several insurance and reinsurance companies, which is really critical to this product, of course. And we couple that with some of the best public sector data. So on the left side of this table, you'll see the Property Claims Service, which is a gold standard within the United States. They regularly survey over 1,000 insurance companies around the country continuously for different disasters. Of course, FEMA's National Flood Insurance Program and their Presidential Disaster Declaration data is important. USDA's Risk Management Agency, and also their NASS program as far as how much is planted and the quality of the crops. All of that data is very important. The National Interagency Fire Center out of Boise, Idaho is an excellent source of information for wildfires. The Energy Information Administration, U.S. Army Corps of Engineers, and lastly, but not least, state agencies. The reporting, on the ground reporting from state agencies after disasters, all of that context is valuable. And I failed to mention the X's denote the intersection of the sources I just mentioned with the 7 different disaster types there at the top that we are analyzing as part of the $1 billion disasters product. So all that being said, at the bottom of the panel, you'll see from this data, we're trying to account for total direct losses, which are insured and uninsured values for assets, including the physical damage to the buildings, which would be residential, commercial, and government buildings, all the content within those buildings, of course, time element losses such as business interruption, or even if you're out of your house while it's being repaired, that adds up. Damage to vehicles, boats, offshore energy platforms like in the Gulf of Mexico. We saw a lot of damage in 2005 from Hurricanes Rita and Katrina. Public infrastructure, of course, is critical for getting commerce back to where it was pre-disaster. So that's damage to roads, bridges, buildings, ports, you name it. That's really important information we try to gather. And also agricultural assets, which would be crops of all types, annual crops, perennial crops, of course, livestock and commercial timber. But it's also important to note what we are not able to capture at the bottom, which would include natural capital losses, mental and physical healthcare related costs, which are substantial for as the magnitude of the disaster rises. I think those costs rise, but again, the heterogeneity of the data doesn't allow us to analyze that at the moment. And also we capture most of the primary and secondary costs, but there are downstream ripple effects such as supply chain, which I think are more tertiary, those are not captured in our analysis. So this analysis is effectively a conservative baseline of what we know was lost, but it's not truly the total cost because we can't measure all of those costs. We won't spend much time on this, but this is basically the metadata behind all of those data sources, public and private, I just mentioned. Talking about the spatial resolution, the update lag time, the data latency, and of course the data sources and the variables they actually are trying to convey to us. And of course, changes in recording thresholds are important to note over time since this is a 40-year analysis. So let's get into the actual analysis. Section 3 here is about what happened last year in 2018. So many of you may have seen this map. This is one of many maps we've got. This is perhaps the most eye-catching. Basically, each icon is trying to represent the geographic center of these disasters, these billion-dollar disasters. So last year in the United States, we had 14 such disasters with a total cost of $91 billion and at least 247 fatalities. So as you can see, we had many different types of events. We had 8 severe storm events, which would include tornado, hail, and straight line thunderstorm wind damage, or any iteration of that. 2 tropical cyclones, of course, that would be Michael and Florence, which were very devastating. 2 winter storms in the Northeast, and of course, drought and wildfire. Now, 2018 was historic. We hear the word historic a lot these days. In fact, probably the last 3.5 years have been quite historic regarding extremes in the United States. So last year in 2018, it was the most costly wildfire season on record at $24 billion. And that had that surpassed the previous record set in 2017, which was about 18 billion. In fact, it's probably closer to 20 billion because there was some data latency in that that happened after we did our analysis. And what's interesting about this is when 2017 set the record, it actually tripled the previous record for wildfire damages in a season, which was set back in 1991 at $6 billion, all inflation adjusted, of course, to present. So we went from 6 to 18 to 24. So wildfire seasons are indeed trending in the wrong direction in the United States. And of course, we know Canada has also had some challenges in recent years with really destructive wildfires. Okay, and here is a pretty loaded slide. There's a lot of different data layers on this chart. So this shows 39 years from 1980 through 2018. The bars, the height of the bars represent on the left y-axis the number of events per year, and they're color-coded by the 7 different disaster types. The spiky gray line is the annual cost, and the lines around that are the uncertainty. We use Monte Carlo simulations to quantify uncertainty surrounding all of these costs at the disaster level, and of course we scale that up annually. And then the black line is the 5-year cost average, and you can see how that's gone up and down, but it's at a new peak now. But what really stands out are several things. One, well, 2018 had the 4th highest number of billion-dollar disaster events. You see there behind 2017, 2016, and 2011. It also had the 4th highest cumulative costs at 91 billion, as I mentioned. And but it pales in comparison to what happened in 2017. You see that was in excess of $300 billion, driven by Hurricanes Harvey, Irma, and Maria, in addition to the California wildfires during 2017 and many other smaller events. And of course, that event, or 2017, took the title away from 2005, which of course was Hurricanes Katrina, Rita, Wilma, and some other events. But I think the bottom of the slide really is a takeaway. So for the full period of record, 39 years, the average annual cost for the United States for just these billion-dollar disasters is about 43 billion, inflation adjusted to 2018 dollars. And that was about $6.2 billion events per year. You can see in the past 5 years, that's more than doubled to 99.1 billion on average for the last 5 years, and also doubled the number of events to 12.6 events per year. But as I mentioned earlier, also the last 3 years have been particularly noteworthy. The cumulative, or excuse me, the average annual cost for the last 3 years is in excess of 150 billion, and also at 15 events per year. So lots of hard times for many people, and we hopefully this year will not quite be at those levels. 1 second, let me do that. Okay, so this slide here shows a different slice of the data we just saw. This shows just the disaster frequency as it accumulates January through December for all 39 years in our record. And you'll see the average is the black line there. That's it goes to 6.2 events per year for all years. And you know, you can see I just mentioned that the years that really stand out, which would be 2017, 2011, and 2016. And in red, that's 2018. So again, it's the fourth highest billion-dollar disaster frequency. And again, you see how it's not only many events, it's a wide variety of events. We always have many severe storm events. A lot of that, of course, is driven by increased exposure, but also tropical cyclones, non-tropical inland flooding, which we've had more of. Actually, let me go back one slide. I'd like to highlight in blue here is the non-tropical inland flooding. And again, last year, I guess, was a bit of an outlier. We actually didn't have any billion-dollar non-tropical inland floods, but in 2019, of course, we have 2 so far. That's still being analyzed. But you can see in the blue, I failed to mention that we are seeing more of the extreme heavy rainfall events from non-tropical flooding events in the last 10 years. Okay, so back to this, again, more events in more recent years. Let's go to the next slide. This is the same slice, except for rather than look at the disaster frequency, we're looking at disaster costs. So again, the red line is 2018. It was 4th place. What I like about this slide is you can see the clustering of all the 39 years, pretty much between about 10 billion and about 40 billion. You see the distribution, but then you see the outliers above the distribution, particularly 2005 and then 2017. Even 2012, you see, was 3rd place, and of course that was Hurricane Sandy, and then the historic 2012 drought, among many other events. In fact, 2012, yes, many other events. So again, not trending in the right direction. Also, I'd like to note the second bullet on this slide shows that in 2018, 80% of the total losses were from the combined effects of Hurricanes Florence, Michael, and the California wildfires. So the distribution of losses does get is expressed through the most extreme events often each year. And here's an example of a state, the same slice of information. This is for the state of Alabama for the last 39 years, how the billion-dollar disasters affecting the state of Alabama, what that looks like. And again, you see the distribution is between about 100 million and about 1.1 billion. The average is the black line there, which is just under $1 billion per year for the state of Alabama. But again, what's interesting is the outliers, because that's what we're always preparing for, you know, across NOAA, is try to help people make better decisions and to mitigate their risk. And the outliers here, you can see the years are color-coded, are the hurricane impacts in 2005 and 2004. Alabama had in excess of $6 billion for each of those years. Also, 2011 was a massive tornado outbreak. I think several outbreaks in 2011. That was also above $6 billion. Last year was about $2 billion, which was still also 4th place for Alabama for its period of record. But I think the most interesting thing to note is that what were the outliers? They were tropical cyclones and they were severe convective storms. And so you'd say statistically those were more likely to be what's facing Alabama from a risk perspective in the future. And you can do this analysis interactive on our website for all 50 states plus Puerto Rico and the Virgin Islands, U.S. Virgin Islands. So all this data we're trying to make it transparent as possible, despite the fact that we do have proprietary data we have to protect. So the last section of my talk is the cost comparison and mapping. This is perhaps the most interesting from my point of view. So from 1980 through 2018, we have analyzed 241 separate billion-dollar weather and climate-related disaster events. of course, each with at least $1 billion of direct losses. We also every year go back through the full period, the full distribution, and adjust prior events that were not under $1 billion for inflation. So we always get new events from the past into our database, which are sprinkled across the time series, as you'd expect. But the cumulative cost for these $241 billion disaster events exceeds $1.6 trillion. What I have circled on this chart are some takeaways. First, probably does not surprise you that tropical cyclones, which are of course hurricanes, have the highest lost share within this analysis. $919 billion of the $1.67 trillion is from hurricane impacts, which is about 55% of the loss total, but they only represent about 17.5% of the total events. So what that means, of course, is the average event cost for these events is also the highest at about $22 billion per event for hurricanes. But what does surprise people is drought. Drought is, the silent, slow, sometimes deadly hazard that seems perpetual. Of course, right now in the United States, we're in a very drought-free time, and that's great news. But sadly, we have the opposite end of the spectrum with extreme inland flooding across the Midwest. But to my point, drought is roughly $250 billion of damage in the United States since 1980 at $244 billion. And the average event cost for these drought events are $9.4 billion. So that's also second place only behind hurricanes. To the top right, you'll see deaths. So those are associated with heat waves, which are, of course, sometimes associated with droughts, not always. And we saw a lot of more pronounced heat waves in the 80s and early 90s, which is what those deaths are in relation to. Lastly, at the circle next to severe storm, again, that's tornado, hail, and straight line thunderstorm wind damage. That has the highest number of events at 103, which is about 42% of the full total. But also, the average event cost for these is the lowest at $2.2 billion per event. And one more point I'd like to make. So flooding, this would be non-tropical inland flooding. That total is, of course, going to go up quite a bit after we do our analysis for 2019. And some people would look at that number at 124 billion, say that sounds kind of low. And flooding is, again, these are just for the billion-dollar events. Flooding is certainly a challenge, and we're getting more and more extreme heavy rainfall events, which are causing more and more damage. And in fact, the National Flood Insurance Program just released all of its data back to 1978 for the first time ever about a week ago, and it's open. And it allows people to finally get more transparency into flood loss data. So we've had access to that data for a while, but now with more people looking at it, I think that more interesting research may come out of flood damage. And of course, with hurricanes, flooding is also a big driver of loss in addition to the wind and storm surge. Okay, so as a nation, certainly, no matter where you live in the United States, you have some hazard or multiple hazards to think about and to potentially prepare for, as each geographic region certainly faces unique hazards. This is the 39-year period of record cumulative footprint of the frequency of all these different billion-dollar disasters broken out by each type. So you can see in the top left corner, drought in particular is fairly ubiquitous. I mean, the northeastern United States is perhaps has seen the least of that, or at least the least damage related to drought, whereas the deep south and the south central states, where we have a lot of agricultural assets, and that's a big part of the economy, they have seen not only a lot of drought, but a lot of damage from those events as well. The top center would be winter storms. Probably also does not surprise people that the Northeast has the most really severe winter storms. These largely are nor'easters as they form off the New England coast, and the high wind, the snow, the ice, all that really can interrupt commerce. Top right, you'll see tropical cyclones anywhere from Texas, of course, through New England. But also, it's hard to see on this slide, but we also track tropical cyclones as they transition and become extratropical and move far inland, because that's when they really unload their precipitation and have lots of, they create a lot of damage from flooding. So, you can see, Missouri and Illinois and Ohio and all the states in between have been impacted, and we have data on that. Bottom left, flooding. So this is the non-tropical inland flooding I just mentioned. Also, you see how the flooding generally follows the tributaries into the main branches of the rivers, and then outflows up to the Gulf of Mexico or toward the oceans. And consequently, the number of billion-dollar disaster inland flood events kind of mirror what you'd expect with how floods amplify in magnitude as they work their way through the United States, with Louisiana and Texas and Arkansas really having their fair share of flood events. Bottom center would be wildfires. Of course, California seems like the perpetual epicenter for damaging wildfires. Also Alaska, we have, Alaska in the southeast has its fair share of wildfires. Not the scale and the intensity and severity of what's in California, but still they create damage. And lastly, bottom right would be severe local storms. Again, like droughts, fairly ubiquitous. Most all of the country, of course, sees storms, but you can really see the heartland there, where the highest percentage of these events happen, and that really stands out. So if we add all of these maps together, this is what we get. We see that the U.S. South, Central, and Southeast regions have experienced over the last 39 years a higher frequency of these billion-dollar disaster events than any other region of the United States. And Texas, of course, really stands out as having the most events. Of course, there's a spatial bias with Texas because it's so large and has a large population with assets and large cities to strike. But also Texas gets not only the most events, it really gets all types of events as well. There's not really an event type it doesn't see. So this is just a snapshot of the frequency. But the next map I'm about to show is the cost. So same setup, except for this is the cumulative cost over the last 39 years for all these billion-dollar disaster events. And again, Texas also leads in that category. It received about $250 billion of damage. All the numbers I'm speaking of today are inflation adjusted to present day dollars, but $250 billion of damage from all these different hazards. Florida is second at about $225 billion. Now, Florida, of course, it is mostly focused on its damage is mostly with hurricane damage. It also receives damage from many other event types, but hurricanes really skew the distribution of losses in Florida, as one would expect. California, New York, the Southeast, even Puerto Rico, all these other regions have really had their fair share of damage as well. Also, this information I'm showing you, you can get on the website and you can download the information, you can interact with it dynamically via maps, tables, charts. So this is really just the surface of what I'd encourage other people to look at. So essentially this map reflects the severity and the vulnerability of different regions to a variety of weather and climate events. But there's yet another layer one would want to consider, which is how each year each state's relative economic output, which economists refer to as GSP, gross state product, or GDP, how that relates each year to the percentage of the costs received from the billion-dollar disasters. And so in 2018, you see North Carolina led the nation in regards to the size of its GDP versus the size of the costs from these billion-dollar disasters. And of course, Hurricane Florence is what you're seeing here. 3 to 5% of the North Carolina annual economic output, that's how much damage was received. And this is just one example of a filter we have on our website, a data filter, to let you look at the data in a more nuanced way or ask different questions about the data. But also Georgia and Florida from Hurricane Michael, they're at 2 to 3%. Certainly the farmers in southwestern and southern Georgia, the pecan farmers in general, have suffered tremendous loss. That will take probably a decade to recover from. And of course, Mexico City, or Mexico Beach, also devastated. But again, you'd have to get on the website, and you can create many of these maps. One thing I haven't shown you here today is how the Midwest and even how the Dakotas, since they're largely agricultural driven economies, how their losses as a percentage of their state output is significantly higher than many other states, as you'd expect with a drought or a flooding event. So I would encourage you to get on the website and see how that changes over space and time. And with that, here are some resources. The top is the website for the $1 billion disasters. The second link shows, this is a report we wrote at the end of, well, it was published in February this year about last year, going into a lot more detail than I even spoke about today, talking about the geophysical and damage cost records in historical context. My email is in the center. And lastly, we have some peer-reviewed publications. This is not all of them, but these are probably the primary publications that you can look at that gives you more insight into our analysis. With that, I would be happy to take some questions. Thank you.
That was an excellent presentation, Adam. Thank you. So again, at this time, we will take questions. So you can type your questions in the questions pane of the GoToWebinar control panel, and I will read them aloud to Adam so he can answer them. So while you're typing them in, we did have a question from Victor from yesterday. He emailed, I see where you've already shown the 2019 February-March upper Midwest flooding as one event. How about it has lingered now into June? Not sure if this results in $1 billion impact, but is it one event, a separate one?
Yes, so indeed, we will separate that into two events. The March in the upper Midwest, and then the May into June event, and more in the southern plains, Arkansas, Oklahoma. I think Victor had it right in his previous email how he would have separated it. We did something similar back in 2011 where we had a major flood along the Missouri and then another major flood in the Mississippi River Basin. So, you know, floods can be a bit subjective as far as how you parse it, but I think that this year, just like 2011, there's enough time and space between the extreme precipitation and the duration to really clearly articulate those as two separate events. So that's, in fact, I believe it'll be on Tuesday, July 9th is our Q2 release of this analysis. I failed to mention that this is a quarterly product. So the first week of January, April, July, and October, every year, and every quarter, we're updating our analysis and our whole website, and we usually put something out as far as through the media about this.
All right, great. So we did get a question: is the website accessible to public or just from NOAA computers?
It's a public-facing website. Anyone can download or interact with the data. And if you have questions, certainly email me at adam.smith@noaa.gov.
All right, excellent. So we don't have any other questions at this time. So a reminder, if you do have questions, please type it in the GoToWebinar control panel at this time. I'll give it another minute or two for any lingering questions. So is there anything that the $1 billion disaster is going to incorporate in the future that is not part of it now?
That's a great question. So we're always thinking of better filters to analyze the data with. I'll mention a few things. So last year, I believe it was last year, we added the economic versus disaster costs at the state scale and at the event scale as far as our mapping. We also added another filter that scales the losses per 1 million people at the state level. So these are just different ways to slice and dice the data to see. It basically allows you to ask different questions or more questions about the data. But I think one thing that we're focused on in the near term also that is not available now is trying to better couple the geophysical variables with the cost variables. So actually, we at NCEI and monitoring, DCAR is the head of the monitoring branch. We have so many different data services and products, and lots of great information regarding data values, anomalies, looking at standard deviations, looking at how extreme are extreme events, because of course it's relative to where it happens, and of course to what type of period of record and what type of data set you have behind it. So we want to take all that great monitoring data and couple it with this relatively robust socioeconomic disaster data, which are the billion-dollar disasters, because I think there's a lot of interesting insights if we overlay the two macro data sets, so to speak. So so that's something to look for probably in the next 6 to 12 months.
Awesome. So we did get another couple questions. On your website, is it available to view a breakdown by state only, for example, number of events, cost, type, etc.?
Yes. So you can, for example, you can look at, actually, when we do our analysis here in the next couple of weeks, we will be above 250 separate billion-dollar disaster events going back to 1980. So you'll have 250 separate mapping suites where you can look at all the states affected. You can look at the cost per state per event. Now, one thing we've had to do, though, we've had to bend the state event level cost data. For example, $500,000 or from 1 billion to 2 billion and 2 billion to 4 billion. We've got it bend. And the reason we have to do it that way on that particular part of the website is because of the proprietary nature of a lot of the insurance data. Basically, we can't get it too transparent where people could reverse engineer and expose some of the insurance data, because then, of course, that would be a problem. But yes, I think the answer is yes to your question. If you want another breakdown that may not be readily apparent to you on the website, just simply email me and I can help to address that.
All right, excellent. And the next question is, will there be a future update? For example, instead of saying a particular number of billion-dollar events, would inflation then make it a number of 10 billion or 20 billion-dollar events, such as Hurricane Irma, for one example, here in Florida, an economic damage around 77 billion, yet it is listed as one of the $1 billion events for 2017.
So yeah, you could go on the mapping and look at Hurricane Irma, and you could see a map of how much Irma actually was for the state of Florida, for the state of Georgia, for any state that it hit. So I don't know if I totally understand your question. When we say billion-dollar disasters, that's just a general phrase that says that this event, whether it was one state or a regional event, which most of these billion-dollar disasters are in fact regional events, not just a single state with a billion-dollar disaster on the state level. But anyway, that data you can see if you go to the website, and you'll understand a bit more how we parse the information. Yeah.
All right. So I'm not seeing any more questions at this time. So again, if you have any additional questions that you'd like Adam to address, his email is listed on the screen, adam.smith@noaa.gov. So with that, thank you again to Adam for your presentation, and thank you for everyone for attending and participating in today's presentation. Give us a few days and we'll have the materials from today's seminar, including the recording, posted online. So thanks again for your participation, and this concludes our webinar for today.